Okay, and on to our second example here. So now what we're going to do is, again, the first thing is we need to get 0 on a side by itself. So I'm going to just go ahead and take away the constant here. It's going to be 3x squared plus 3x minus 6 equals 6 minus 6 is 0. Now I'm going to replace the 0 with y and just rewrite this as 3x squared plus 3x. And since it's plus c, I'm going to change this to plus negative 6. And that is my function right there. Okay, so the very first thing I should be able to tell is it opens up because of my positive a value. And now I need to find the vertex, which again, the x-coordinate is the opposite of b over 2a, which in this case, the opposite of b is negative 3 over 2 times my a, which is 3. So that's negative 3 over 6. So my x equals negative 1/2. So now I solve for y. And again, since my x is negative, I'm going to keep it in parentheses so I remember to square negative 1/2. So it's 3 times negative 1/2 squared plus 3 times negative 1/2 plus negative 6. Well, negative 1/2 squared is 1/4 times 3 is 3/4. 3 times negative 1/2 is negative 3/2 plus negative 6. Okay, well these two together make negative 7.5. Okay, so I'm going to go ahead and write that down. That's negative 7.5. And I've got 3/4 here that I have to add on to that. So negative 7 and 2/4 plus 3/4, well that is going to give me negative 6 and 3/4 for the y value. So my vertex is at negative 1/2 and negative 6 and 3/4. So now again, our job is to fill in x values on either side of this and 3x values on either side. So I'm going to go to the next lowest whole number, which is negative 1. Then I'll go negative 2 and negative 3. Then I'll go up from there. I should go up 0, 1, and 2. Alright, so again what should happen is, look, I got negative 1/2. So here I went down 1/2 and here I went up 1/2. Then after that I increased by 1 each time. So my numbers on either side of here should be symmetrical. So I should get the same number here as I do here, and here as I do here, and so on. Okay? Okay, so I took a screen break so that we could do this math here, and when I solved out for these points, I didn't show all the work in here. You need to make sure you do that. Okay, but this is what I got for my points. So again, look at how symmetrical this is. I got a negative 6 on either side, a 0 on either side, and a 12 on either side. That's a good thing. Okay, so let's move on to the graphing portion of this. Alright, so we're going to go ahead and graph this here. We'll go ahead and just number this by ones. So I'm going to go to negative 1/2 and negative 6 and 3/4. I'm going to go down 1, 2, 3, 4, 5, 6, and about to 7. Okay, so I'm going to be kind of right in the middle there. Okay, now again, it's hard for me to make my point there, so you can be a little more accurate than that when you do yours, but that's about at 1/2 and negative 6 and 3/4. Then it should be at 0 and 6, so I'm going to have a point right there. And at negative 1 and 6, so another point right here. Then I should have a point at 1, 0. And another point at negative 2, 0. Then I should have points at 2, 12. So I'm going to go up about to here. It's going to be a little off my graph. And at negative 3, 12. About up to there. So again, now you can see my graph opens upward. And I'm going to try to just connect these as best as I can. Oops, sorry. Making my parabola like that. And again, my roots are where my graph crosses the x-axis. So I've got a point at negative 2, 0, and a point at 1, 0. So my solutions to this equation are x equals negative 2 and 1. Okay, those would be the solutions to my original equation that I had to start with. And you can plug that in to check and see. Alright, now that's your lesson on graphing quadratics. Again, I know it's time consuming, okay, but it is a valuable way to be able to solve these equations. So, good luck on the homework.